Okay, so with binomial distribution, another thing that we must be able to do is to calculate our expected value, which is the same as saying mean, and our variance. So now with binomial distribution, remember we only have two outcomes, a probability of success and a probability of failure. And our probability of success is going to be our p-value, and then failure would be q, which is we can calculate as saying 1 minus p. So for a mean or expected value for the average, all we need to do is take n, which is our total number of times we do things, and times it by the probability of p. So that's the probability of getting that thing. For the variance, we are going to take n times p times q. So that is our total number times the probability of success times the probability of failure. And then the other thing we also need to be able to do is we can find a value of n when we are given a probability, because we always know that if I have my lowest number being 0 of things for successes, that would be the same as saying q to my power of n, and if I have the maximum number of successes, that would be p to the power of n. So now when I have a finding n situation like that, I can always use this formula to be able to find something, because I will be given a probability. So I could either be using p or q, and if that's the case, I would have to my power of n, and I would say that it's greater than or less than, depending on the probability that I'm given. And in this kind of situation, once I have a sum like this, if I have n to the exponent, I can take n down to the bottom by saying log. And as soon as I add a log, it means I can take this n and put it to the front of that log, like that. And then I have to log the other side as well. So as long as I use that word log, and on your calculators you have a log button that you can use, it means I can take that exponent down to the front by adding in log. So if I look at an example of an actual question. So here we can do the first part as our normal binomial distribution. So we have Anand has designed a new logo for a sportswear company, and a survey of a large number of customers found that 42% of the customers rated the logo as good. A random sample of 10 customers is chosen, and we need to find the probability that fewer than 8 of them rate the logo as good. So my probability of success of getting a logo as good is 42%. So that's the same as saying 0.42, which means failure, or Q, is going to be 1 minus that 0.42, which is going to be 0.58. So now I have P and I have Q, and I am looking for everything that is fewer than 8. So that's less than 8. So if it's fewer than, that's not including 8, that means it's 0, 1, 2, 3, 4, 5, 6, 7, because it's less than 8. So now that's a lot to calculate, so instead I can say that's the same as saying 1 minus my probability of 8, 9, and 10, because those are the only ones I am not including in my less than 8. So that's the same as saying 1 minus, for 8, I'm going to say 10, C, 8, 0.42, because it's p to the power of 8, 0.58 to the power of 2, plus for 9, it's going to be 10c9, 0.42 to the power of 9, 0.58 to the power of 1, and then my last one is my maximum of 10, so I can say 0.42 to the power of 10. And when you type that into your calculator, you get an answer of 0.983. So now, the second part, where we have to find n, like I was talking about. So, on another occasion, a random sample of n customers of the company is chosen, and we need to find the smallest value of n for which the probability that at least one person rates the logo as good is greater than 0.995. So there we're given the probability of 0.995, and that is for at least one person. So that means it's everything greater than 1. So the only things not included in that would be 0, because it's everything greater than 1. So just like up there where I said everything that's excluded, I say 1 minus, here I can do the same thing, because it's everything greater than 1. So since I'm excluding 0, I can say that's the same as saying 1 minus the probability of having 0, because then that is everything more than 1. And I was told that that probability is greater than 0.995. So that means it's greater than 0.995. So now I have a sum that I can sub into, because I know that the probability of getting 0 would be having q to the power of n. So I can say 1 minus my q value, which was 0.58, to the power of n is greater than 0.995. So now I have an equation where the only thing missing is n, and I can now solve for n. So the first thing I want to do is get this value with n by itself. So the easiest thing to do would be to switch this one with that one, because then I can say 1 minus 0.995 greater than 0.58 to the power of n. So now I can say 1 minus 0.995 in my calculator should give me 0.005 for my value, 0.58 to the power of n. And now I want n down in the front. So what I'm going to do is log both sides. So I can say the log of 0.005 greater than n log 0.58. Because as soon as I add log, I can take that n to the front of that. And now I want n just by itself. So to do that, I need to divide this by that log, because I need to take that over. And as soon as you divide by log, it means the sign will change. So now I'm going to say log of 0.005 divided by my log of 0.58. But because I took the log over, this sign changes direction to be left with just my 9. So now my n is greater than that value. And when you say log of 0.005 divided by log of 0.58, you get an answer of 9.727 in your calculator. So n is greater than that value. But now, since we're dealing with a customer in a company, you can't have 0.7 of a person. So we need to round this off to a whole number. And this, since that's 0.7, our smallest whole number, we would get as 10. So we can say that n equals 10 being our smallest possible value for n. So that's how we would find a value for n. And it always follows the same way, so you're always going to log it, because you will always end up with a value to the power of n, either p or q, depending on what information we're given.